Rotate triangle ABC 90 degrees clockwise. All right, so let's first talk about the clockwise direction. This is the clockwise direction. If you're not sure about clockwise and counterclockwise, just look at a clock, an analog clock, and look at the second hand and note the direction it's moving in. That's clockwise, okay? So clockwise, and this is counterclockwise, the opposite of clockwise. Okay, so clockwise. So this is clockwise. And we're rotating 90 degrees clockwise. Now there's a few tricks that you can use to make sure that you're rotating correctly. Okay, so this is a 90 degrees rotation. Now, the easiest thing to do would be to pick up your iPad and rotate the whole iPad. Okay, so you want to rotate the whole iPad and just see where your shape ends up. Okay, so our A, which was at -1, +10, ends up at +10, +1. So click on your shape to copy, click on the rotating button, and rotate it to that point. Be as accurate as you can, and there you go. A couple of other tricks you can use. Another trick is called the toothpick trick, the toothpick method. When we rotate the axes, if you look at the y-axis, it's going to rotate down here and become the x-axis. So this point right here, which is 0, 10, is going to rotate down here and become 10, 0. So you can imagine a little toothpick sticking out of this 10 into the A. So when the 10 rotates down to here, that toothpick is going to be pointing straight up into the A. Okay, so as you can picture that toothpick in each instance, then you can plot the points quite accurately. There's another method. If you look at your A is -1, +10, and your A prime is +10, +1. Okay, so the X and Y switch position, but the X also switch sign. We can use a mapping notation saying that the XY gets mapped onto Y, -X. So the X and Y switch position, but when the X moves and becomes the new Y, it also changes sign. If you look at your C point, for example, it's -5, -1, so that's going to become -1, +5, like that. Then we click on our check button to check to see if we're right. 90 degrees counterclockwise. Now remember, this is clockwise, so counterclockwise is going to be the opposite direction. This question happens to be quite easy because we're right on the axis with the A. So I'm just going to, when the x-axis rotates up, it becomes the y-axis. So this point 5 on the x-axis is going to become the 5 on the y-axis, like that. Okay. I want you to notice a few other things. If we're looking at the B is at 2, -7. Okay, and you can use your toothpick method for that, right? The 7, you have a little toothpick sticking into the B from the -7. This 7 rotates up to here, and the toothpick would be sticking straight up into the B. So you can picture it that way. But let's look at the coordinates of the B. 2, -7, and here we are at 7, +2. Okay, so +2, -7 became +7, +2. So what happened? So the X and Y's switch position again, but in this case, the Y, when it became the X, it also switched signs. Our point, our C point, 3, 2, okay, so the 3 goes to the back, okay, and stays 3, but the 2, all right, goes to the front and becomes the opposite, -2, all right, so 3, 2 becomes -2, 3. One other method, okay, this is a very simple method for any 90-degree rotation, clockwise or counterclockwise. What you have to do is establish where your shape or where your points are going to end up. Are they going to end up in quadrant 1, quadrant 2, or quadrant 3, or quadrant 4? All right, whenever you do a 90-degree rotation, I want you to notice that you only move into the next quadrant. Unless you're on an axis, then you move onto the next axis, right? If you're on the X, you move on to the Y. If you're in quadrant 1, like the C is, you move into quadrant 2. If you're in quadrant 4, like the B is, you're going to move up into quadrant 1 if you're going counterclockwise. If you're going clockwise, okay, you're going to move the opposite way, but you only ever move one quadrant. Knowing that with a 90-degree rotation, that you're always moving one quadrant, and also knowing that the X and Y's are going to switch position, Well, just ignore the signs at that point, right? So you can look at your B point and say, look, I'm ignoring the signs, so I'm at 2, 7 in quadrant 4. I'm going to move up into quadrant 1 at 7, 2. Okay, the C is here at 3, 2 in quadrant 1, so I'm going to move over to quadrant 2 at 2, 3, ignoring the signs. Okay, so the ignoring the signs method, it's really fast for 90-degree rotations, clockwise or counterclockwise. All right, so we click the check button to check if we're right. We're being asked to rotate about the origin positive 90 degrees. Okay, now positive 90 degrees is this direction, okay? This is the positive direction. The reason that's the positive direction is, think of, you're looking at the sun as it goes across the sky, right? It starts in the east and sets in the west. So the sun rises in the east and sets in the west, okay? And then comes around again. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4 for those reasons. So when we're rotating in the positive direction, we're going counterclockwise. Think of it that way, all right? If you look at a protractor starts off at 0 degrees, and then 90 degrees, and then 180, and then 270, and then 360. So if you're rotating positive 90 degrees about the origin, you're rotating 90 degrees counterclockwise. Okay, so I know I'm looking at the negative 12 here, and I'm imagining a little toothpick sticking out of the negative 12 into the A, so I can do the same thing over here. Okay, so the 12 rotates up to here, and the toothpick is now pointing down into the A. You could use the ignore the signs, switch the coordinates trick. All right, so if I'm looking at the A is in quadrant number 3 at 112, and I'm ignoring the signs, so 112 in quadrant 3, so it's going to be 12, 1 in quadrant 4. All right, because your points are only ever going to move one quadrant over. All right. .270 clockwise. Click on the shape to copy, and then, okay, so that's 90, that's 180, and this is 270, but that's a lot of work, and I'm a little bit lazy, so I don't want to do that. I don't want to go around 90, 180, 270 like that. Notice that it would have been just a lot easier just to rotate 90 the opposite way, okay, because 270 clockwise is 90 counterclockwise. Okay, just something like that. Remember that 90 one direction is 270 in the opposite direction. And there we go. Alright, so 270 counterclockwise is going to be 90 clockwise. And I'm just looking at the A is on the 12, so I'm going to bring it up here to positive 12. We're being asked to rotate about the origin positive 180. Okay, so positive 180, so this is the positive direction, okay, and 180 is like this. Now I want you to notice a couple of things. If we're looking at this A point, okay, we're at 3, negative 8, and our A prime is at negative 3, positive 8. What's happened? The X's and Y's have stayed in the same position, but they've switched signs. Okay, so if they were positive, they became negative. If they were negative, they became positive. That's it. So whenever you're rotating 180, and it doesn't matter whether you're going clockwise or counterclockwise, okay, if you turn around, it doesn't matter whether you turn to the left or you turn to the right. Okay, you're still facing the opposite direction you were facing. Okay, so 180 clockwise is the same as 180 counterclockwise. The direction doesn't matter. And what happens is your coordinates only change signs. Okay, if they were negative before, they're now positive. If they were positive, they're now negative. Okay, and that's it. So your C, which was at 7, negative 2, is now going to be negative 7, positive 2. I also want you to notice the little lines that are going through each point and the copy of each point, right? So these little yellow lines. Please notice that on a 180-degree rotation, they pass through the origin. Click the check button to check to see if you're right.